analysis of polar graphs, we're going to compare them to the trig graphs we made back in chapter 4 and begin to look for patterns. We'll do this over several days, so don't be nervous if today's work goes a little slowly for you. I'm going to try a couple of examples, but I'm going to have to toggle between two screens to do it, so it could be interesting. Okay, so we're going to graph r equals -2 cosine theta plus 4 as a polar graph. But first we're going to graph it as y equals -2 cosine x plus 4, a trig graph from chapter 4. I've already set myself up for this. I have a vertical shift of 4, amplitude of 2, and a reflection. So the highs will be low and the lows will be high. There's nothing happening to x, so I have my regular tick marks along the x-axis. So I am ready to plot my graph. It's cosine. Normally starts high, but since it's negative, it will start low, middle, high, middle, low, middle, high, middle, low. That's two waves of a cosine graph. Okay. Now what we're going to do is we're going to try to use this to tell us how to graph our trig graph. Okay, so we're going to be toggling back and forth. Apologies for that. So it starts out with 0 for theta being at a radius of 2. Okay, so we're now going to treat this as our theta, right? And this as our radius. Okay, so at 0 we have a radius of 2. At pi over 2 we have a radius of 4. And at pi we have a radius of 6. Okay, so how does that look? At 0 we have a radius of 2. At pi over 2 we have a radius of 4. And at pi we have a radius of 6. Okay, so let's go back and look at how this was drawn. This was drawn in a continuously increasing sweep, right? So this graph is continuously getting bigger. All right, so as we draw this, we have to be getting continuously bigger radii. So if I were to approximate it, it's like it's a little longer on this one, and a little longer on this one, and a little longer on this one, and a little longer, and a little longer, and a little longer, 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 longer. So it's going to take a look sort of like this. And again, those guesses in between are just guesses. Okay, oops. So now let's go back and see what happens. At 3 pi over 2, we have a radius of 4. And at 2 pi, we have a radius of 2. Okay, so at 3 pi over 2, we have a radius of 1, 2, 3, 4. And at 2 pi, we have a radius of 2. And in between there, what's happening? Well, in between there, their radius is getting smaller and smaller and smaller, right? It's going from a radius of 6 to a radius of 2, which means on all these intervening radii, we'll be getting shorter again. So shorter and 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 shorter until we get back here. So whoop, a steady hand is a good thing, and well-placed points are a good. Whoop. All right, so this is the shape. What's going to happen if we continue to go forward? Oops. It's going to start again. It's going to repeat itself because my graph here is repeating the exact same pattern. So if I'm back at the start, I'm going to end up repeating my drawing. So this is the complete drawing. It looks like a heart shape. It looks like a cardioid. And so I've drawn it rather than from a table of values for r and theta, from sort of using the trig graph as a guide. So let's try that again. I have r equals 2 sine of 5 theta. That's going to be my polar graph. But I'm going to do y equals 2 sine of 5x, a trig graph, to see if I can guide my efforts. So we do have a period change. So 2 pi over b would be 2 pi over 5. Tick marks at 2 pi over 5 divided by 4, so it would be pi over 10. So you notice I counted by pi over 10s for a while. Amplitude of 2, and this is a sine graph. So from the middle to a high, back to the middle, to a low, to a middle, to a high, back to the middle, to a low. I may have put too many tick marks out here because I've got lots of sine waves. I've got, that's 1, that's 2.5 sine waves. Interesting. So I'll see how much of that I need. All right. So it looks like at 0, oh, let me show you what I did to my graph. I needed it to be in pi over 10s. So I brought in a protractor and I measured out pi over 10s. So I have pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, 5 pi over 10, which is pi over 2, 6 pi over 10, 7 pi over 10, 8 pi over 10, 9 pi over 10, 10 pi over 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pi over 10. So these are in pi over 10s. I did that so it would be easier for me to make my polar graph follow my trig graph. Okay, so at 0, I'm at 0. At pi over 10, I'm at 2. And at 2 pi over 10, I'm back at 0. In between there, the radius increased and then decreased. Okay. So at 0, I'm at 0. But at pi over 10, I'm at 2. And at 2 pi over 10, I'm back at 0. So somehow the radius got bigger and then smaller pretty quickly. At 3 pi over 10, I'm at negative 2. Now that's very interesting to draw, a radius of negative 2, which says go the other way. And then at 4 pi over 10, I'm back at 0. So at 3 pi over 10, which is 3 pi over 10, I'm not at positive 2. I'm at negative 2. Let's see, that's this one, negative 2. And then I'm back at 0. So, and my radius got bigger and then smaller. Okay, at 5 pi over 10, I'm at positive 2. And at 6 pi over 10, I'm back at 0. And again, the radius got bigger and then smaller. So at 5 pi over 10, I'm at 2. And at 6 pi over 10, I'm back at 0. So the radius got bigger and then smaller. Oops. Okay. At 7 pi over 10, I'm at negative 2. And at 8 pi over 10, I'm back at 0. And the radius got bigger and then smaller. But at 7 pi over 10, I'm at negative 2. Okay, so this is 5, 6. It's 7 pi over 10. I'm not at positive 2. I'm at negative 2. Let's see, negative 2. And the radius got bigger and then smaller. Oh, I keep going the wrong way. Okay. at 9 pi over 10, the radius is at 2, and at 10 pi over 10, it's at 0. And again, the radius got bigger and then smaller. So at, let's see, this is 5, 6, 7, 8, 9 pi over 10, the radius is at 2, and the radius got bigger and then smaller. Oops, I may have drawn that too big. It almost looks like I've completed my drawing, but let's see what happens if I go forward. Okay, so if I continue this and say, okay, 11 pi over 10, 12 pi over 10. Okay, it's going to go negative 2, 0. So it's going to come this way. Okay, so at 11 pi over 10, I'm at negative 2. And at 12 pi over 10, I'm at 0. So at 11 pi, see this is 10, this is 11 pi. I'm at negative 2. And at 12 pi, I'm at 0. And I increase and then decrease. So I am starting to redraw the same thing. So at 10 pi over 10, I actually had completed the cycle, and it's just going to restart. And what is this picture? This is a 5-petaled rose. Now that could be some pretty scary stuff for you, but I do want us to get started, be as fierce as possible. And if you end up in a pickle, you can always make a table of values, you know, an R and theta, well actually theta and R, table of values and graph, and then see how well the trig graph informs that. But this is just our first day, so don't be too panicked.